Thank you, Terence. It's fantastic to be presenting again with Neil on another webinar of yours. And it's also a great honor to be following on from a lot of fantastic presentations there. So we're looking forward to presenting to you. I'm John Mark Seymour. I'm the UK site director, run our headquarters facility, and I've been with Haydale for 9 years.
Yeah. Myself, Neil Bias. I'm Material Science Manager at Haydale, and I'm supporting John Mark and the team with the various R&D projects.
Okay. So just a quick summary of Haydale as a business for everybody's benefit. So Haydale is a advanced materials company and a solutions provider for these new novel materials. We've got a global footprint with sites in Thailand, Korea, the USA, and 2 sites in the UK. This is to help with local support and local supply of our technology and products. I'm calling today from our headquarters facility in South Wales in the UK. Bit of a nutshell sort of approach to our technology. We have a sort of end-to-end product offering in a range of different market sectors. We focus at the start from the supply chain. We have a supply, when you speak about graphene, of over 250 grades that we can identify for the products. Our core technology, which I'll speak about in a minute, is functionalization. So I know a lot of people understand wet chemistry and the requirements for that for energy storage devices, but we have a dry process, which I'll cover in the next slide. But what we often look at is sort of 3 main uplifts in products. That's electrical conductivity, key for today's discussion, mechanical strength, and thermal conductivity, also important for batteries. And these different sort of uplifts can be applied to a number of products. And Haydale has products and works with customers in a wide range from aerospace materials, blood glucose sensors, elastomers, rubbers, tires, shoe soles, as well as sports and construction. So it's quite a large sort of portfolio of industries we work in, but they complement each other and also help us drive innovation for energy storage devices. This slide here is sort of a flow path for our unique core technology. That's the HD plasma functionalization. So this process here is how we unlock the potential of graphene and other advanced materials. People have been trying this product in industry for some time now, as we've seen, and everyone started to identify the need for some sort of surface chemistry modification to the materials. With our process, we always start at the end use. What are we trying to achieve? What does the customer want? And what is the measure for success? Once we've identified that, we can look back through this flow chart also at similar works and case studies and products that we've already done, and we will identify the right material for this, the right grade of graphene, or is it a carbon nanotube, other materials, traditional materials, carbon blacks, graphites, magnesium dioxide, all of these we can identify and select from a technical point of view, as well as a supply and price point. And that's one of the unique aspects of Haydale, is having this full vision of what the technology needs. We've got adjustable chemistries, we've got adjustable levels of chemistries. Our process is a single stage, high volume, patented, protected, environmentally friendly process. You can see in the top right there some images of our reactors. We have a HT60, a lab scale machine, HT200 pilot plant, HT1400, you can see in the image there. So that's the high volume, hundreds of tons per annum. And then we've also got HT4000 system available. So it's a scalable process. It's a controlled process. It's all data logged. And through this process, we can see the potential of graphene realized in a number of applications, especially energy storage.
So as John Mark mentioned, Haydale is a global technology solutions provider company. With our process, we are passionate about creating next generation advanced materials to improve mechanical, thermal, and other essential properties for battery industry. This process is patented, as you already mentioned, and we believe this process can enhance nanomaterials properties, and it can take the lead in batteries and energy storage applications. Haydale can offer a range of solutions for battery industry, starting from capacity enhancement to thermal management in electric vehicles and other similar systems.
One thing we'd like to mention today is one of the unique factors of Haydale's technology, and this is the green aspect of it. A lot of people now, and especially with energy storage, are thinking about the future, about the green aspect of these processes. Traditionally, with graphene enhanced batteries and other sort of energy storage devices, people have had to turn to some traditional methods, whether that be, a lot of additives, a lot of extra chemistries, a lot of downstream processing, or the inclusion of high amounts of precious metals. That's the traditional approach. And when it comes to applying graphene, wet chemistry methods are needed: Hammond's method, oxidation, acid treatments. What we have at Haydale is a low power, low temperature process with no effluent stream, and this can help our customers who adopt this technology with brand protection, but also having a lower impact on the global environmental impact of these technologies. And that's something we're very, very proud of, and a real USB to our product offering.
Yeah, so our technology is clean, environmentally friendly, and it's also suitable for high volume manufacturing of functionalized graphene. And this spatially actually provides the large scale volume material supply to industries like batteries and supercapacitors and EVs as well. With Haydale's process, the key here is to disperse functionalized material in resin and other similar materials, so a uniform homogeneous mixture can be achieved for the manufacture of battery electrodes, and same for supercapacitor electrodes as well. And our plasma functionalized materials such as graphene and other nanomaterials can lead to enhanced electrical, physical, and other electrical and other properties. This functionalized material can also improve high capacity and energy density in batteries, which we will learn later on in the presentation. So why graphene is so important, and not only any graphene, is Haydale graphene with Haydale's functionality on top. So basically, our graphene with functionalities on top can enhance batteries' lifespan. It can also be used for thermal management, such as better heat dissipation in battery systems. It can also enhance battery safety. And last but not least, it can also improve batteries' fast charging capacity. So commercially, we are focusing on three main areas: dealing with batteries, supercapacitors, thermal conductors, and highly electrically conductive electrodes. And some of the application areas where our materials can be applied are inks for battery electrodes. Inks may contain functionalized graphite, graphene, and carbon nanotube materials. Not only that, we are also looking at novel battery chemistries where we can introduce our functionalized materials for better ionic conductivity. At the same time, we can also look to introduce binder-free coatings for various battery electrodes. Alongside of that, we are also interested in graphene silicon hybrids for high capacity batteries, and we are also looking at boron nitride enhanced thermal systems for EVs, so better heat dissipation can be achieved. And for rapid prototyping, we are also looking at boron nitride graphene based 3D filaments for some novel research and development work. We are also looking at low cost solutions focused at graphite based materials for low cost batteries, for EVs and other low cost batteries for automotive application as well. To the next slide, John, please.
Yeah, just to add to this, Neil, I mean, there's a huge portfolio there, not just for Haydale, but many advanced materials companies. And what can this do for them? And you can see here in this spread of applications that not only are we, approaching these and developing Haydale's product range into batteries and energy storage, we're confident in the development path as well. So we'd be interested in any questions at the end of this webinar about what you might have, or if any customers want to approach us, we'll address the challenges that they are facing and identify the right grade of material and the right functionalization to give them the uplifts that they are seeking.
and some case studies basically to show how our material can be beneficial for batteries and supercapacitor industries. Starting with functionalized graphene, we have demonstrated our amine functionalized graphene basically improves the specific capacity of batteries by 19,000 milliamp hour per gram at a current density of 200 milliamp hour per gram. And it also improves the cyclability of the system as well. Functionalized graphite, we have demonstrated graphite with fluorine functionalities can actually lead to higher discharge capacity compared to the unfunctionalized counterpart. And higher discharge capacity is very important for batteries. So from there, we can learn a lot of things about these kind of enhanced systems. Currently, we are working on binder-free coatings, just because if we take out binder from the system, we could improve the battery's capacity. At the same time, we could improve the electrical performance as well. So the image on the left, you could see a copper anode coated with binder-free coating, doesn't have resin, just highly robust graphene-based coating on top, which is mechanically stable and electrically really superior compared to all the inks and additives that they add in resin-based coatings. And finally, graphene ink that we have is actually capable of producing 165 milliamp hour per gram capacity, which leads to energy density of around 190 watt hour per gram, with an average cycle capacity of 80 cycles. This is our standard ink that we use for electrodes. Some other case studies based on supercapacitors. So we developed some asymmetric supercapacitors made of our plasma-treated FLGs, which are few layer graphene, and they performed outstandingly well, around 50% higher capacitance than untreated FLGs. The reason for that is better electrical performance that we obtain from nitrogen-containing functional groups that are beneficial for this sort of enhancement. Finally, we have ammonia-treated graphene materials, which is basically suitable for water-based supercapacitors based on water-based electrolytes. And that basically these type of functionalized material can lead to lower internal resistances, and in turn, that results in around 66% increase in the specific capacitance, which was obtained from functionalized material compared to its unfunctionalized counterpart. So through these case studies and the presentation, we are basically showing the benefits of our functionalized material for battery industries and supercapacitors and various upcoming technologies that are coming in the future. And we are basically interested in supporting our customers through this type of development work, providing novel solutions and products.
Oh, perfect. And one thing it's worth highlighting as well, these key case studies that we've shared, is there is a development path that we've taken to get to this, and we know how to apply our product. So going back to that flow chart we had a few slides ago, what we've done in each one of these cases is we've looked at the challenge and the solution and the uplifts that are required. We're able to select, we're not biased to any material, so we can select the right material for the application, again, cost and volume. And then through our functionalization process, we're not just unlocking the benefits of graphene and other materials, but we can boost the performance. We can add specific surface chemistries that can make these materials, as you've seen here, improving the capacitance nature of them, making graphene more conductive by adding surface chemistries with additional electrons. We make products hydrophobic, hydrophilic. We also adopt our other technologies from our thermal dissipative products, our anti-corrosion products as well. And that shared learning internally at Haydale has reduced the development cycle for our customers and also enabled the technology that they may have been working on for many years. This plasma functionalization process, again, it's scalable. We've got systems around the world, it's reproducible, and we're starting to see the market wake up to the requirement for surface chemistries. This is our final slide for the presentation today, and it's a bit of an overview again on our ethos and our approach to energy storage market. What we've learned with graphene and our customers is that to develop these technologies, and the market's starting to adopt them as well, is it's a through process support that we offer. We don't just manufacture functionalized material. We identify the right grades and the right levels. We work with our customers to formulate the products, develop the prototypes, mix, master batch, and scale up the technology. And we also understand the measures of success. How can we measure this? How can we quantify it? And how quickly we can get these to the market as well. And that understanding has been over the last 10 years with plasma functionalization and working with a number of graphene suppliers and end users as well. Through surface engineered functionalized nanomaterials, Haydale is further enhancing the energy storage market. So again, I'd like to thank everybody today for joining, and we're looking forward very much to the questions, Terence.
Thank you, John Mark, and thank you, Neil. Can you guys just stop the share for a moment and we'll go into discussion. So again, thank you for the presentation. You touched on a lot of different areas. I would assume, and I think you can confirm this, obviously Haydale does not produce graphene. Haydale takes graphene from different suppliers, enhances it on behalf of clients. So I assume that the vast majority of the details of the work that you perform on actual, improvement lifts and that sort of thing is under NDA. Yes, it very much is. And part of our, product offering is a unique benefit to our customers. This technology is so innovative. It requires a collaborative approach, not just from our suppliers, but our customers as well. So a lot of the key products in early development, we haven't seen the rapid market uptake in graphene and energy storage devices that we're starting to see now. But you're right, Terence, a lot of it is covered by NDA, but we do ask if anybody's got any questions, they can contact us, Neil or I, afterwards, and we can have a look at how we can work together. Okay. I just want to point that out because with some of the other presentations, we get quite specific on performance metrics. And I just want people to understand that you guys are in a little different position. I do have a question for you though on the innovation, because you have seen so many different forms of graphene. You work with not just graphene, but other nanomaterials for functionalization. How much is driven by, it's a graphene producer that comes to you and says, this is a problem we're solving? How much is an end user? And how much of your own innovation do you guys do? You say, hey, look, there's a problem we've identified. We think we can create our own solution. How do you approach that? Well, I think the approach is actually changing. We're starting to see now that the market is waking up to graphene. They're starting to see the price of these materials come down and it being more palatable to their application. So over the last 10 years, we've innovated and developed a number of products that have shared properties that would be beneficial to the energy storage market. And now we're seeing that a lot of customers are approaching us with a problem that they want solved and they've seen somewhere else. What we've also seen time and time again is we're dealing with companies that have worked with graphene 6 years ago, 5 years ago, and they've tried something with it. They've been supplied some sort of material and maybe they had success, but again, they had the price point issues. They had the manufacturability issues with it as well. And our USP is taking that, what they've done and what we've done, because as Neil mentioned there is quite a bit of technology we have that's not bound to customers, the material supply that we can work with, again, to give you that higher capacitance, that improved conductivity. We're also driven by a lot of reach requirements. There's a lot of materials that are being used in the energy storage market that are under sort of review from local legislation around the world and being phased out. So we're a lot, we can be, with graphene and carbon-based materials, I think they're a suitable alternative to some of those products. That's an important point. From the first presentation of today from Mark Copley at Warwick and WMG Group, it was identified that one of the objectives is to reduce the amount of solvent in the coatings that are applied, and we understand that that's really important, right? In using graphene in a solvent or in an ink, it typically is a low percentage, which means a high percentage of solvent. Have you guys addressed this particular problem, and is there anything you can share about that?
Do you talk a little bit about the binder-free one we've got?
Yes, so to address that issue, we have seen that problem occurring in this development work, and that's why we have developed binder-free coating, which doesn't actually require use of resin or any type of solvents. And especially for battery industry, they use NMP, which could be a problem, or DMSO. So we addressed that, and we developed this binder-free technique where we don't use any solvent or anything like that. And it deposits, the process is proprietary to Haydale, so we can't go into too much details, but that process deposits a uniform layer of graphene on top of the electrodes of your choice. It could be either copper or aluminum or stainless steel.
And as well, you know, there's a lot of lessons learned from our inks range that we've been using for printed electronics too. Through the functionalization process, we're able to use, you know, put higher loading into the material, reduce the viscosity of it. That reduces the requirements for solvents too. But our functionalization process is a dry process. So there's no effluent stream. The powder is drier than the raw material supplied to us. So that opens up a lot of avenues for many different applications in energy storage. And it's a growing market for Haydale. Our bigger markets are our printed electronics, our composites and elastomers. But we're finding now that the gestational period for these new products is significantly shortened by the shared learning from our other technologies. And we're really looking forward to the up and coming years in this market sector.
Absolutely. You guys have certainly accumulated a unique perspective on the different types of graphene that are available in the market, how to manipulate them, and how to use them. One of the things I was impressed with the presentation you gave was the number and range and types of functional groups that you're able to use. I didn't realize it was quite as broad as it seems to be. And there is a question from one of our audience asking, you know, why use amine functionalization? Is that for high capacity, I assume high capacitance, and or improved electrical conductivity? Can you talk first, you know, yes, what is the limit on the range of species and groups that you can add through functionalization? And then secondly, specifically, why the amine groups for battery applications?
Yeah, so we haven't even listed all the functionalization chemistries that we can do at Haydale. We're continuing to innovate. We've got quite some new technologies that we're releasing at the moment with the silane chemistries, special mixes of chemistries, and some more novel applications too that we're looking at through our technology with blended materials. And it's probably about all I can say on that. What we often find with our customers, and to answer your second question, Sarah, in a second, Terence, is we talk about our functionalization process for the first meeting, and then everything is about uplifts and how we try and get that end result. We're focused on the uplifts, we're focused on the measures of success, and then our internal work, and we'll share the chemistry with the customers, would be developing and choosing the right chemistries and the right levels. Amine chemistries have been very key for different matrix, trying to interact with the correct matrix that we're working in. But also we see some innovation there with some nitrogen groups as well around that, providing improved conductivity that we can see there too. So that was something that was first identified through our printed electronics. And then we did some studies into supercapacitors with pre-treatments and post-treatments and quenching, and identified some really good results through our amine functionalization.
Excellent. I do have another question from the audience, and then I'm going to hand over to Dexter to see if he has any questions for you. But the question is about your experience using graphene oxide. And of course, you know, again, for those in the audience, some of you are very familiar with graphene, some of you are less familiar. So graphene typically is electrically conductive, highly electrically conductive. Graphene oxide can have somewhere between 30 to 35% oxygen content typically, and turns it into an insulator so that it's non-conductive. So the question, John Mark, is if using the plasma functionalization process, Has it been used for oxide reduction, so oxygen reduction, to turn graphene oxide into a reduced graphene oxide, or is that simply a byproduct of what happens anyways if you functionalize graphene oxide?
So there's two aspects there. The first thing I'd like to mention is we can oxidize graphene through our process. So we can get up to 28% oxygen on the surface of material, and that's with no oxygen tied up in impurities as well, okay? So we can generate what we like to call plasma oxidized graphene oxide. But as you mentioned, it is insulative. So for this application then, if we do want any specific oxygen groups, we would only put as much as needed, sometimes as little as 4%, to help interact with the matrix. And then that is less detrimental to the electrical conductivity of this material. What's also worth mentioning is we try and not change the morphology of our material. That helps with a lot of legislation, but it also helps with maintaining the electrical conductivity of these materials because we don't damage the crystalline structure. So that's the initial approach for there. Cleaning and reduction of materials as well is something that we do. So a lot of materials we receive might have moisture or impurities from the manufacturing process or additional oxygen. So what we can do then is we use different types of treatments and different types of temperatures in our process to remove, to clean what we say, the nanomaterials. And then we also have advanced steps to fill any defect sites and reactive positions as well with another chemistry that won't detriment the process. So as we mentioned, it's a very tunable process. We've tried a number of feedstocks as well in there, and we understand fully it's not a dark art anymore. It's not academic. It's sort of a plug and play process for us, and we can quite rapidly get the chemistry needed.
Excellent. Thank you. I had an image in my head of you guys being the repair shop for graphene, right? So people can bring their material and
it's almost like we're the repair shop, and then we also soup up your car at the same time.
There you go.
There we go.
And Dexter, our senior analyst from Madrid, Dexter, do you have a question for the gentleman from Haydale?
Yeah, you were talking about how your market breaks down now. You primarily still composites and elastomers. What has been the market trend over the last couple of years in terms of your work with batteries and battery chemistries? Has it gone from like 10% of your business to 20, or how would you measure that?
Yeah, so I think, again, to reiterate, our core technology is a material supply. So that's our core focus there to customers. And I'm not at liberty to talk about percentages today, but there has been a huge drift from two things. COVID has had a huge impact to a number of industries. The aerospace market is one of them, as well as the current focus on environmental technology as well. So we've seen a massive shift in some markets due to COVID, and then we're seeing an uptake now in the requirements for batteries and being driven by price as well. So we've seen customers that have developed technologies in batteries come to us with challenging price points or supply issues. But I think it's a growing market for us. It's up and coming, and it's also something that we're ready to go with, adopting our standard range of conductive products already for this market.
Thank you, gentlemen. I think we've come to the end of our time slot. There are a couple of late questions that just came in at the end, technical questions, and I invite our audience to contact you directly to put those questions to you and get in contact. You guys are a unique resource in this field, acting as this specialist function of improving or enhancing graphene materials. Thank you for your time as always, and really appreciate that. Thank you.
Thank you very much, everybody. It's been our pleasure.
Thanks.
Goodbye.
Thanks.